Hello, welcome back to the channel. So let's do one more question on the concept that we did in the last video, which was about taking the derivative of a definite integral. So if you have not watched the previous video, I would first suggest you to watch that video so that you can get a clear idea about what theorem we are talking about, and then you'll be easily able to understand this problem as well and the concept that we'll use in this video. So let's first have a brief overview about the concepts that we did in the last video. So whenever you have to take the derivative of a definite integral whose endpoints are also functions, you basically evaluate this expression. So what you do is you first plug your h of x into f of x and then take the derivative of h of x, have it in one term, and then you do the same thing for g of x, and then you'll subtract both of these components. So that is why I first suggested you to watch the previous video so that you can get a clear idea about what we did in the last video and what we would be doing in this video as well in order to solve the derivative of a definite integral. So now let's go over the question. So the question is, your capital F of x is this, and you have to calculate, based on the capital F of x, you have to calculate the slope of the tangent line to y equals capital F of x when x equals 3. So now, first of all, we have to calculate the slope of the tangent line, which is represented by y equals capital F of x. And we also know that the slope of the tangent line is always dy by dx, right? And since in this case our y is capital F of x, we will take the derivative of capital F of x. And our capital F of x in this case is a definite integral. So that is why we'll use this property, we'll use this theorem in order to calculate the slope of the function, and when we'll have the slope of the function, we'll substitute x equals 3 in order to calculate the slope of the tangent line that we are talking about. So now let's first write the function and then calculate the derivative of this function first. So I'll write f of x again. So in this case, our f of x is, capital F of x is integral 2 to x e to the power 1 by t dt, right? And we'll do the same thing that we did in the last video. We'll first identify our f of x, h of x, and g of x. So in this case, our f of x is clearly e to the power 1 by x. Since we are calculating f of x, that is a function with respect to x, that is why we changed every occurrence of t in this case with x. You can use t as well, that wouldn't make any difference, but we just did this process in order to make things more simple. That wouldn't change your answer as well. So you can go forward with t as well. The process will remain the same. So now we have f of x. And now if we notice h of x, our h of x is clearly x, which is our upper endpoint in this case. Our g of x is our lower endpoint, which is also clearly 2 in this case. So now since we have our functions, let's calculate the derivative of capital F of x. So I'll separate this component out, and then you have to calculate d by dx of capital F of x. And in order to do that, since our capital F of x is a definite integral, we will evaluate this expression. So let's try to evaluate this expression over here. So the first thing we'll do is we'll plug the upper endpoint into the function and then write its value, which would be e to the power 1 by x, right? And then you'll take the derivative of the upper endpoint in this case. So if I take the derivative of x, I would represent it as this, and then I have to do the same thing for g of x, right? Which would be, and since I have to subtract this term from the g of x expression, I'll write the minus sign and then I'll do the same thing for g of x. So if I do the same thing for g of x, I'm basically plugging this endpoint into this function. So this would be e to the power 1 by 2, and then I'm taking the derivative of the lower endpoint. So the derivative of lower endpoint, which would be represented by d by dx of 2 in this case. And now let's evaluate this expression. And now if we try to evaluate this expression, it would be e to the power 1 by x would remain e to the power 1 by x. Dx by dx would become 1, right? Because I'm taking the derivative of x, so derivative of x is 1. So this would be changed to 1. And now we'll work upon the other half of this expression. So e to the power 1 by 2 will remain e to the power 1 by 2. D by dx of 2, since 2 is a constant, your derivative of a constant function is 0. So it would be 0, right? And further simplifying it down, you'll get e to the power 1 by x as your answer, right? Because this expression would be 0, so you'll only be left with this, which is e to the power 1 by x. And since we calculated this, that is precisely capital F dash x, right? And now we have the answer to capital F dash x, which means that we have the slope of the tangent line to this function. But we have to calculate the slope at a specific point, which is x equals 3. So in order to do that, we'll just substitute x equals 3 into the derivative expression, which would be, so I'll calculate, in order to calculate the slope of the line which we are talking about, we'll do f dash, since it's x equals 3, we will substitute x equals 3 on the right hand side as well, which would become e to the power 1 by 3, that is cube root of e. And that is indeed your final answer. This is the slope of the tangent line to y equals capital F of x when your x is equal to 3. So that's it for this video. In this video and in the previous video as well, we talked about taking the derivative of definite integrals and how using this expression we can calculate these type of questions and solve them very easily. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.